Hello everyone, welcome to the webinar about PDF P&IDs within UPV. My name is Christina Rech. I'm product owner for everything related to PID inside UPV and also for some other tools which we have in our company. On the agenda for today, we have the following topics. First of all, I will explain about how this digital twin can be created on the basis of PDF PIDs. I will also explain a little bit the results in a few slides. So there will be two live demos later on, one about what you can do with the data inside the digital twin, and the other one about using the same data, for instance, to perform a task or use case like plant inspection. First of all, where do the PDF files come from? They can come from different sources, for instance, from AutoCAD, from MicroStation, from Comos, from Visio, from all, let's say, vector graphic systems which are able to create PDF files. It is not possible to convert, for instance, a scanned drawing, paper drawing, to IntelliPID inside UPV. So we don't have a real, let's say, object recognition inside the tool. Once you are using those files inside UPV, you can really do a lot of things based on them. So there is no real need to, for instance, convert them to a real authoring tool. You can also use UPV for redlining, for markups, for sketching, and also for inspection planning or other tasks like system subdivision and whatever else. What is also important to know, the PDF files, they can come from different sources and they can be combined into one package. This means if you have some files, let's say from MicroStation, other files from AutoCAD, you can really put them together in the same package later on. What do you need to do to prepare the PDFs? First of all, of course, they need to be analyzed. So here, for instance, we can see some graphical objects, we can see some labels placed on them. And our tool, which is converting the data, is called PDF Bit Adapter. And this tool is able to create what we call semi-intelligent PIDs within UPV. This means the graphic is represented. It can also be selected, for instance, to change the color or to copy to a sketch item and whatever. But the graphic is not really intelligent. What we are doing is we are taking the main labels, we run them through a text recognition, and the text recognition based on regular expressions, which of course can be defined also by you, the client, is able to create objects. So in this case, for everything that matches a letter, a dash, and then 3 digits, it will create an equipment object. And for everything that has the structure of this valve label, it will create a valve object. What I also want to mention is that we have done a little bit of work on this tool as well, and it is also possible right now to work with what is called regex substitution. So this means in principle you could even create more than one attribute from such a text. You could say you want to have the item tag, but also separately the prefix and the sequence number. And for the line labels, it's possible to export separately the fluid code, sequence number, and so on. Okay, what is the next step? The next step is to use UPV Builder and create the digital twin package. This means in UPV Builder, you can decide if you want to create a package which is only based on PIDs. In that case, you would only work with the file coming from the PID conversion. But you can also say you want to combine it with a 3D dataset. And in that case, you will create a package which contains both sides, PID and 3D. In addition, when you create that package, of course, all the clients, they want to map the PID objects with the 3D objects, assuming that such a combination, of course, is possible. And the method that we allow to be used is that we can use a file. It can have any name, but in this case, it's called mapping XLS. And in that file, you can define which equipment from the IntelliPID side should match which equipment on the 3D side. So here, for instance, you can see this is the equipment name coming from the PDF. And if it has the same value like the name attribute in 3D, you can then combine it with the 3D object. And this means the builder will automatically create a link between those objects. The link is represented here in the dark blue color, and you can jump from one side to the other by identifying objects. Also here, it is possible to do some little tricks. So for instance, if the PID site would contain a dash, but the 3D site may be a slash or a blank or nothing in the name, you can configure it in such a way that those special characters will be ignored. And you even have the possibility to revert sequence of attributes so that if a line is called P111 on the PID, but 111P on 3D, you could really match the attributes in such a way that the objects will find each other, even though they are not spelled exactly the same. Because from the PDF files, not many attributes will come directly from the file, it is very useful that UPV Builder also allows to enrich those attributes using what we call an SDK. And this means that it is possible to use a plugin when the builder runs. In this case, this one is called Plugin Excel Import. And with that plugin, it is possible to import additional attributes, of course, based on a source value, which in my case is like the item tag for equipments and for pipe runs. And then you can add additional attributes like manufacturer, technical description, and pressure temperature, and so on. And I will show you later how the result looks like. There is another possibility as well. If you want to also add additional documents, there are two ways of adding documents. One is using the document adapter. It is if it's more like a large-scale document definition. But you can also use a link file, which, if it's located in the right folder inside the data package, will allow you to put additional links on top of some objects. So in my case, I have associated this pump with a datasheet. The datasheet is located on the file system, and if I click on the link, the datasheet will open. So it is started from inside UPV, but it will be opened as a regular datasheet. Okay, now I will talk in a few slides about the results that you get from this conversion. So as you see, within UPV, you have the graphic, and also you have all those texts. And if you click on the item tag of the pump, for instance, the P004A, you will have access to the attributes which come from the PDF PID adapter, but also to the attributes which were created by the builder if an SDK was used. So in my case, you have the name, the task, and of course the drawing, which come from the adapter. And in addition, maintenance date, manufacturer, technical description were added using this external Excel file, which was included in the builder when the package was created. In addition, we have the link to the 3D site, which comes from the builder, and we have this pump datasheet entry here, which was added by using the link file when we started UPV. What can we do with this dataset? Of course, we can do what we can always do with UPV. We can search for attributes. So everything that is available on the attribute level can be searched for. It will be a search across the complete package, in this case PID and eventually also 3D. And of course, you can also use the document search inside IntelliPID. So you can also search for texts which will not have some link to 3D or which have not attribute representation, and they will be found by this document search button. Of course, you can use the link to go to the 3D site and also the other way back, which I will show in a few minutes. You can create reports from all the attributes which are available inside the dataset. So this is now an example for an equipment list. And you can see here the complete equipments from the two drawings. You can see the manufacturer in case there is one defined. And from the reporting engine, it is very easily possible to jump to the corresponding graphical object. And of course, from there, eventually to jump to the 3D site if you want to see it also there. What else can you do with the PIDs? You can, of course, create markups. So if there is a need to mark some items and some objects and put a graphical item around them and also some text, you can do it. You have here a very nice interface where you can select the color and also the shape of the graphic and configure all these things. And the markups, they will be saved, of course, with the association to the corresponding PID. You can have multiple markups for one PID, but of course you can also have different markups for different PIDs. Another very important function is the possibility to create sketches. In this case, I called it a redlining on top of the PID. So for the sketches, you can use regular objects, which I will show later, but you can also use objects from a catalog. The catalog can be converted from existing tools, and then you can also add eventually your own symbols to be placed on top of the PIDs. The last thing which I want to mention from the slide point of view, there is one use case, which is to make a plant inspection, and for that it is necessary on the PID side and probably also on the 3D side to place what is called inspection points. They might be related to existing objects. They might also have additional information like, I don't know, if a valve is necessary to be opened or closed or things like that. And here we have defined a particular new item. I called it inspection point, and you can insert a number inside, but eventually even a text if you want. You can place them associated to existing objects, and they are not part of the dataset. They are part of the sketch, which means of the document that you create. And also you can create reports based on those objects. You can view them in graphics if you like from the report, and you can also create a documentation, which means a PDF file of the complete drawing, including those points. You can create the associated report that will show the list of the points inside the PID, eventually with some additional properties. And you can also mark 3D objects if necessary with kind of a similar information that you have on the PID. Okay, with this said, I will switch to UPV and I will try to show those functions now inside UPV. First of all, I will open the PDF PID inside IntelliPID. So this is a conversion that was done from a PDF file. You can see that it contains, let's say, the complete graphic. But if you click on a graphical object, no attributes will show. So I can click on the heat exchanger, I can click on the vessel. There is nothing that I can see here. But if I would like maybe to change the color for some objects like these two pumps, I can select the color menu here. I can change the color. I could create a screenshot. I can revert the color. So this is possible. If I click on a text like the equipment label, you can see that there are attributes which all in this case were created by the PDF bit adapter. And of course, if you want, you can use the link to go to the 3D side. If I click here on a pump label, I will see more attributes, and this is what I mentioned in the slides. I have the regular ones coming from the adapter, but I also have things like maintenance date, technical description, manufacturer, which come from the SDK. So this means they were enriched using the Excel file, and they are available for everything that you want to do, reporting, searching, and so on inside UPV. In addition, of course, these objects, they have their link to 3D, which I can use to jump to the 3D side. I could click here on a different object and then use the link back, coming to the other pump on the PID side. And then, as I mentioned, it is possible to associate datasheets to certain objects. So if I click here on the pump datasheet, the datasheet will open, but in this case as a regular PDF. So now I am triggering a link to an external file. Yeah. With the other method, using the document adapter, it would be possible to add those datasheets and see them here in the list of documents. So if anyone is interested how that is working, just let us know. Okay, and also what I want to mention, there is a regular search function, like if I want to search for 3-inch, the software will just go through each of those texts, even though they are not really intelligent texts in some ways. And I can also use a button here, which is called Show Linked Objects. And then only the texts which do have a link to some other site will be displayed in black and the rest will be grayed out. So this is also, I think, a quite useful function. In the next step, we will search for an attribute value like KSB in the search engine. In this case, the result means that this manufacturer was found on 2 different PIDs, and on each one actually for probably the 2 pumps which you see here, and I can just click on the search result, the corresponding PID will open, the objects will be highlighted, and they will also be selected so that I could also jump to 3D if I'm interested. So this is the search engine, which works very well. Yeah. And you probably already know it from your other applications that you use inside UPV. What I also want to show you is that you can create reports. So if I click on equipment for active drawing, a report will be generated with the 3 pumps which I have in the active drawing. But of course, in this report, I have the possibility to switch to all elements. In that case, the report will be created from all the equipment objects having this manufacturer and description and so on. And then I could click on one or more objects and I can use the highlight function. It will jump to that object. If I also want to see it in 3D, I can use the link and also go to the 3D side. Okay, now the next thing that I want to show you is that we can also create markups and sketches on top of these documents. And before I start to show that, I want to mention so that everyone is aware, our data set is always a read-only data set. So this means whatever I do, even if I only change a color for an object, or if I start to create some markups and sketches, it will always be an add-on which is stored separately and it will not change the original data set. So in my case, I'm starting a markup and I open this markup function, and inside I can choose some colors. I could switch, for instance, to red and maybe make the line a little bit thicker. And then I could make this little circle around this valve and eventually also add a text here where I say delete. And if the position is not really the one I really like, I can just use this move button and move it around. This is also valid for the text. And I could create a separate markup, for instance here, where I want to point out that it's necessary to place some safety valve. So I will create a separate one, change the color, in this case to blue, make it a little bit thicker, and then mark the position and place another text called place BSV. Okay. And now I have two, and I want to show you another one as well. And in this case, I want to use the green color. I want it to be a little bit thicker, and I want to make an orthogonal line, which means with this function, I can really click on top of existing objects. The line will always be horizontal or vertical, and this makes it very easy to, use this function as you are doing it right now with a pen on a paper PID. Yeah, and you can save all of them. Now you have these three markups. You can very easily activate each of them, and then you will see it in the graphic. If you want to edit one, you can use the edit button, and then you're back in the edit mode, and you could continue to sketch something in here with the markup function. So this is all really pretty easy. And if you want to save them away, you can use the save button here, put them in a certain folder, and then reload them at a later time so that you have those markups. If you start your work tomorrow, you can use them again. So much to the markup. I will now come to the sketch, and here I will open the sketch function. I will go a little bit closer here. I will activate another color for the sketch because it's supposed to be a redlining, and I can now start to route a new pipe. I will take it from this corner. I will go here and maybe close it over here, and I will place a valve, and I will take a pump from the catalog. I can put it over here. It is also possible to change the size if necessary because there is a scale factor available. And then I can also maybe place some other objects like a valve here on top. And if I would like to copy this pump, this is possible. I can select it. I can use a copy button. I can place it somewhere. And okay, I can also delete it if I want. And last thing which I want to show you in the sketch, it is also possible to hide existing objects. So there is a hide function. And if I save the sketch now, those things, they will not show anymore. And if I want to revert them back, I can do that by using a revert button, and then they will be visible again as they are originally. Also, it is possible to place objects which have a text inside. So in this case, if I want to place this as a new instrument, I could call it maybe FI and then give it a sequence number. And then you have a new instrument which you can relate with the line using this line function. And also these objects, as you see, if you want to move them closer or further away from the original pumps, you can use those buttons to move them around. So this is a very nice sketch function. And of course, when you make a PDF, everything that is visible on the file will be also saved into the PDF. And this is then a documentation which you can send to anyone who is interested in the changes that you have done on the PID. Okay, I will close this sketch now, and I will come to my last point of the presentation, which is about inspection on top of the PID. And therefore, I will create another sketch. I will call it inspection. plan. And now I will go to the position where I want to do this work. And for instance, if I want to do the work on this pump, I could place one point referring to the left valve, another one to the right valve. And for that, I have a special object in here called inspection point. It is related to the valve which I have selected. I can place another one on the right side on this valve here. And I can go a little bit closer. I can give this point the number 23, for instance. And I can also assign another attribute called IP description. And I can choose from a list. I call this one closed. And the other one I will call 22. And I will give it the information that it's open. Eventually, I could even bring that into graphics, associating it to the point. And of course, if I want to change the color for these objects, I just need to use this color function. And then I could print everything in a PDF. And of course, I can also use a reporting function. So if I want to create a report for the inspection points, they will be activated inside the reporting engine. And I can also use the highlight to find those points from the report, as you can see. And if I want, I can also generate the report and print it out in Excel so that I have it available later on somehow on my system, and I can send it together with the rest of the documentation to whoever is interested to see all this information. And the last thing which I want to show you is that if I go from here to the 3D side, also on the 3D side, I could create a comment for this object. And I could say, this is inspection point 22, and maybe in brackets it is open, so that I also have my documentation for 3D. And if I want to point out which object it refers to, I can drag the object name inside here. And now I have the information which I need also in the 3D side, so that I could generate a screenshot and send it to whoever is interested. Okay, so this is what I wanted to show. If you have any questions, you know that you can put them in the question panel. I will try to answer some of them. And of course, I will now go also to my last slide. And I want to thank you for your interest. And I hope that you all are well. And please let us know if you have additional questions. Of course, we will answer them via email.